Permutations and combinations. Good evening. Today's chapter is permutations and combinations. Permutations means arrangement combination means selection. Before we go further, let me explain what is meant by arrangement and what is meant by selection. Let us say we have got three letters A, B, C. The question is permute A, B, C taking two at a time. Then we will have AB, BC, CA, AC, BA, C. Instead of permute, if they say select, then you will have AB, BC, and CA. So here AB is different from BA, or BC is different from CB, and AC is different from CA. Whereas in selection, AB is same as BA. So number of selections are always less than number of arrangement. See, we have got some notations, and I can't go to the details of the derivations, but I will just list the notation that we use. The first notation that we use is called NPR. That is number of permutations of n things taken or at a time. Instead of that, if I write NPN, it is taking all at a time. All at a time. That is taking all at a time. This is taking all at a time. Where formula for that? NPR is equal to factorial n, or we should use other notation, factorial n by factorial n minus r. This is the formula for. I'm just helping you to recall the formulas. We'll not be deriving it. Then we have got NCR. What is NCR? Number of combinations of n things taken all the time. That is NCR is equal to NPR by R factorial. That is equal to n factorial or n minus R factorial into R factorial. Please note NCN is factorial n, whereas NCN this is NPN. NPN factorial n, NCN is 1. So this is NPN means arranging all the n things taken all at a time. That is factorial n. Whereas selection of all the, so there are 5 things. Select all the 5. So that means only one is possible. I'll just explain you the simple way of simplifying NPN so that when we have to work the problem, this method will certainly help you. Supposing we have to find 7p3. What is the formula? NPR is equal to factorial n over factorial n minus r. So if you use the formula, you get 7 factorial by 7 minus 3 factorial. Suppose all of you know what is factorial n? It is n into n minus 1, etc. 1, or you can write it as 1 into 2 into 3 into etc. n. The product of the first n numbers is called n factorial. So what is 5 factorial? 1 into 2 into 3 into 4 into 5. So here, let us simplify this. How much you get? This is the NPR. Okay. Factorial 7 by factorial 4. What is factorial 7? 7 into 6 into 5 into, or you can even write as 1 into 2 into 3 into 4 into 5 into 6 into 7. Divided by factorial 4 is 1 into 2 into 3 into 4. So this will cancel. You get 5 into 6 into 7, that is 210. So instead of writing all this, the simple method of working out is, if you want 7p3, you just write 7 backwards 3 times. 7 into 6 into 5. That's all. You'll get 210. I have worked a problem using the formula. I am suggesting a simple way of working this problem. Supposing you have got 7p4. So then write 7 into 6 into 5 into 4. You have got 11p3. 11 into 10 into 9. So instead of writing this formula and simplifying, this is the easiest method. Now I want 9p3, 9p4. It is 9 into 8 into 7 into 6. So just remember, if it is 9p4, you have to write 9 backwards 4 times. Suppose it is 9p5, you will write one more term. I will teach you the simple way of finding NCR also. Supposing we want 7c5. See, for NCR, you need to remember this formula, this would help you. NCR is equal to NCN minus R. A very important formula. So if you use that formula, 7c5 is going to be 7c, 7 minus 5, that is 7c2. I am using the formula NCR equal NCN minus R. So instead of calculating 7C5, you can calculate 7C2. What is the formula for NCR? NCR is equal to factorial N or factorial minus R into R factorial. Or this is NPR by R factorial. But you know how to find NPR? If you have to find 7C5, you have to write 5 times backwards. 7 into 6 into 5 into 4 into 3 divided by R factorial is 1 into 2 into 3 into 4 into 5. So what will happen is 4, 3, 5 will cancel. So 2 3s are, you get 21. Let us find out what is 7C2. 7C2 is 7P3, 7C2. 7P2 divided by 2 factorial. That is 7 into 6 by 1 into 2. That is 21. So instead of calculating 7C5, you can calculate 7C2, you get the answer. Supposing I want 11P7. So I will write this 11C7. I will write this as 11C4. How to find out 11C4? 11 into 10 into 9 into 8 divided by 1 into 2 into 3 into 4. Can one work it out and get the solution? So I'll just repeat once again because we need to calculate this NPR and NCR. If you want 9C3, it is simply, 9P3, let us take. 9 into 8 into 7, multiply that. Supposing you want 9C3, it is 9 into 8 into 7 by 1 into 2 into. Supposing you want 9C6, don't find 9C6. You first write 9C6 to 9C3. Remember the formula NCR is equal to NCN minus 1. Supposing I want 25C21. It's going to be a very big problem, but you can write this as 25C4, then it's going to be easy. So this is a very useful formula. NCR is equal to NCN minus 1. And sometimes they have given a problem also based on this formula. They have given some problems based on this. Once we start solving the CET problems, I'll just explain how to do it. See, all these things before we start, we need to understand this called fundamental principle. We are going to work problems based on this fundamental principle. It states if one thing can be done, in m ways, a second thing can be done in n ways, then two things can together be done in m into n ways. So we are using this fundamental principle for working problems of permutations and combinations. Now we generalize. If one thing can be done in m ways, second thing in n ways, third thing in p ways, etc. All things can together be done in n into m into p, etc. ways. I'm generalizing formula. If one thing can be done in m ways, the second thing in n ways, two things can together be done in mn ways. Supposing we have a number of cases, one thing can be done in m ways, second thing in n ways, third thing in p ways, etc. Then you can do all of them in m and p ways. So this is what is required, and use this fundamental principle for working problems. With this basic concepts, we'll move on to problems of one more thing we require. Permutations, this knowledge also we need. Of or objects in a circle, in the form of a circle. This is called circular permutations. Circular permutations. See, linear permutations of n objects taken all at a time is n factorial, whereas circular permutations of n objects taken on a time is n minus 1 factorial. So this is what you need to remember. Why it is one less can be explained practically. Supposing you want to form a circle with 5 objects, or you can just imagine 5 of your friends want to form a circle. You just 5 of your friends decide, let us form a circle. And all of them starts moving, you cannot form a circle. So one person has to stand, looking at him, the remaining 5 can form a circle. Therefore, the arrangement of 1 is fixed. The first one, n minus 1. So remember, linear permutation of n objects is n factorial. Circular permutation of n objects is n minus 1 factorial. See, when we form a circle, supposing I form a circle, there are two ways. You can form a circle like this. This is called anti-clockwise. Or you can form a circle like this. It is called clockwise. So when we discuss about human beings in the form of a circle, we'll always take it as n minus 1 factorial. When we discuss objects, because a person will know whether he has come over here in the anti-clockwise direction or clockwise direction. Instead of that, we have a beads, or if we have flower garland. The flower here doesn't know whether it has come clockwise or anti-clockwise. So now what to do is, so we have an understanding circular permutations of objects is equal to half of n minus 1 factorial. The most important thing is the number of arrangement clockwise and number of arrangement anti-clockwise they are equal. So whenever we talk of arranging objects in the form of circle, it is taken as half of n minus 1 factorial. Whenever we talk of arranging people, human beings, we take it n minus 1. Or in the problem it is given, the circular and anti-circular and the clockwise and anti-clockwise arrangement should be treated as same. Then you can always write half of it. So before we start the problems, let us recall what is that we have discussed. We have discussed about NPN, we have discussed about NPR, We have discussed about NCR, and we have also discussed about NCR is equal to NCN minus R, and we have also talked about circular permutations. And we also discussed how to find. Let us take one example. I want 8P3. The simplest method is 8 into 7 into 6. Supposing you want 8C3, it is 8 into 7 into 6 divided by 1 into 2 into 2. Supposing you want 8C5, we first use the formula and write this 8C4, that is 8 into 7 into 6 into 5 divided by 1 into 3. So I have explained how to find the values of NPR in a simple way. 8P3 is just 8 into 7 into 6, whereas 8C3 is 8 into 7 into 6 divided by 1 into 2 into 3. Supposing I want 11P9. So you are going to write 11 into up to 9 terms. Instead of that, of course, you don't, it's a difficult problem. If they give you 11C9, that can be given. So this first we write this 11C2 using this formula. Then you can write this as 11 into 10 by 1 into 2. You may not get 11P9. If 11P9 is given in CET, you can leave the answer as it is. Because it's not that easy to simplify. Writing 11 backwards 9 terms and simplifying it. Normally you won't get. Whereas 11C9 can be given. So that is all we need. One more formula. NCR plus NCR, R minus 1 to N plus 1 CR. This formula we are going to use it in binomial theorem, but just remember it. We may require it for some problem. In KCET problems, we are going to discuss. And one more thing we discussed was fundamental principle. What is that? If one thing can be done in M ways, the second thing can be done N ways, then two things can together be done in Mn ways. That can be generalized to n number of terms. So let us move on to the problems given in C. How many 5-digit? How many 5-digit telephone numbers can be constituted using the digits the digits 1 to 9 if each number starts with 6 7 and no digit is repeated. When I work this problem, if you follow the analogy, you can work any problems of these type. First of all, we should try to understand what is the meaning of NPR. NPR means filling all boxes 1, 2, 3, etc. R boxes with n things. So when you go for derivation, we have done this, but here I'm not interrupted. I'm just recalling this so that working these problems becomes easy. NPR means you have to fill R boxes within objects. So when I go to the first box, I can fill this in n ways. Out of n things, one is already used. So I am left with n minus 1. Therefore, I can fill this in n minus 1. The third is n minus 2. That is why when we say 7p3, it is filling 3 boxes. So the first box can be filled in 7 ways. The second box can be filled in 5 ways. The third box can be filled in 5 ways. Therefore, 7 into 6 into 5. I just gave the formula there, and now I'm giving you the analogy how we work the problem. So if you just recall that, working these types of problems becomes very easy. Now, how many digit number you want? You want 5 digit numbers. So I have 5 boxes. First box, second box, third box, fourth box, and 1, 2, 3, 4, 5. So you can write box. Don't mistake this for numbers. Okay? You have to fill with 1 to 9, but one condition they have given. The first and second box should be 6 and 7. Fixed. So, though it is a filling 5 boxes, 2 boxes are already filled. So our job is to fill only 3 more boxes. So try to understand this analogy. You can work any problem if you can follow what I am explaining. Now the 2 boxes are filled. We are going to fill 3 more boxes. But how many numbers are there from 1 to 9? There are 9 numbers. If I take from 0 to 9, there are 10 numbers. There are 9 digits rather. Out of it, 2 are already used. How many are left over? 7. So you can fill this box in 7 ways. After that, you are left with 6. You can fill this box in 6 ways. You can fill this box in 5 ways. Therefore, number of telephone numbers is equal to 7 into 6 into 5. That is 210. So whatever answer is, I'm sorry, there is some mistake has happened. 1 to 9, how many are there? 1 to 9, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 numbers. Out of these 9 numbers, 2 are used. Therefore, it's okay. Out of the 9 numbers, 2 are used. So you have got 7, first box in 7 ways, second box in 6 ways, and third box in 5 ways, because no number should be repeated. Okay. Let me explain one more problem. How many numbers of 3 digits? How many numbers of 3 digits can be formed using 1, 2, 3, 4, 5? And I have taken this problem to give you a clear idea about this. So this is nothing but filling 3 boxes. To understand the concept, I'll go as slow as possible. Filling 3 boxes. How many digits are there? Of course, no digit repeated. No digit repeated. That's a condition. So you have got 5 numbers. So you can fill up the first box in 5 ways, second box in 4 ways, third box in 3 ways. Using fundamental principle, the answer is going to be 60. Supposing they want 4 digit numbers, we'll have 1 more box extra. Now, let us fill up 4 boxes or 4-digit numbers using the digit 0, 1, 2, 3, 4, 5. Very, very important. Now the thing is, you cannot fill the first box with 0. Why? If you put 0 in the first box, the number becomes 3-digit. I repeat, the question is 4-digit numbers can be formed using 0, 1, 2, 3, 4, 5. No digit being repeated is a problem. So I have taken the 4 boxes. How many are there? 1, 2, 3, 4, 5, 6 numbers are there. Now I can't put 0 in this box. Why I cannot put 0 in this box? If I put 0 in this box, it becomes a 3-digit number but not 4. So you cannot put 0 in this box. So you can fill the first box excluding 0 5 ways. Try to understand that? You can fill the first box in 5 ways. But for the next boxes, 0 can be used. So how many are left over? There are 5 again. Out of this 1, 2, 3, 4, 5, you have used only one of them. 4 digits are left over there, plus one more. Therefore, you can fill up this in 5 ways. Now, how many are left over now? 2 are already used. This in 4 ways, and this in 3 ways. So, number of is equal to 5 into 4 into 3. You can multiply and this. This is equal to 300. I will keep these numbers as it is and try to discuss some other problems, so that with this problem I am able to give you the total analogy of working the problems. How many 4-digit numbers can be formed? How many 4-digit even numbers? Even numbers. Can be formed using, I'll just remove 0. 1, 2, 3, 4, 5. First I'll remove 0, afterwards I'm going to include the 0. So we have got 4 boxes. 1, 2, 3. Why I have left 0 means when I put 0 also, it becomes double condition. First condition is should take care of the last box and also first box. It is not a problem of CET, that's why I'm leaving that. Now, you want the numbers to be even. If you want number to be even, the last box should have 2 or 4. Out of the numbers given, the last box should be either 2 or 4. You must always take up the box which has got some conditions. I would rather say some problems. What is the problem? This box cannot take any other number. So therefore, you have to first fill up this box in 2 ways. Fill up this box in 2 ways. After filling this box, how many numbers are left? You are using either 2 or 4, not both of them. Therefore, again, out of this 5, only 1 is used. So you can fill up this in 4 ways, this in 3 ways, and this in 2 ways. The answer is going to be 2 into 3 into 4 into 2, 48. I'll give you another simple method for these sets of problems. What is the condition here? The number should be even. It should be 4-digit number. So first we have to fill the first box, rather the last box. Can do this in 2 ways. First, tackle the box which has got a problem or condition. What is the condition? The number has to be even. So therefore, you cannot put any other number in the last box except 2 or 4. So that can be done in 2 ways. Only one number is used. How many numbers are left? 4. How many boxes are there? There is no condition. So you can write this as 4p3. You're not saving any time, but this is another way of doing it. So what is the total number of arrangement possible? 4p3 into 2. What is 4p3? 4 into 3 into 2 into 2. This is This other way of looking at things. So instead of writing this, you can, because there are no conditions. Same problem, odd. Supposing they give you odd. What happens if they give you odd? You can put either 1 or 3 or 5. Therefore, this box can be filled in 3 ways. But how many numbers are left over, digits are left over? You are not using 1, 3 and 5, you are using one of them. Therefore, again you are left with 4. So if you want, you can write this as 4, this is 3 ways and this is 2 ways, or you can write as 4p3. Let me work out one more problem. How many numbers, by working these problems, I am covering more concepts so that the problems of CET you can work it out yourself. How many numbers above 6,000 can be formed using 4, 3, 4, 5, 6 and 7. If you want, we can add one more also. So you have to find out how many numbers are there above 6,000. But 6,000 is a 4-digit number. Therefore, it is similar to filling up 4 boxes. This method of working out becomes so simple and so easy that you will never go wrong. Now, which box is very important? The first box is important. Why? We want a number to be more than 6,000. Therefore, you cannot use these 3. Why? If you use 3, 4, 5, that number is less than 6,000. We want a number more than 6,000. Therefore, you cannot put 3, 4, 5. You can put either 6 or 7. Therefore, this box can be filled in 2 ways. Again, same thing. You have not used both 6 and 7, one of them. So, all the numbers are left over 4. How many boxes are there? 4p3. Second one. More than 6,000, number being even and all, we can work it out, but that's going to be lengthy and they will not give double conditions problems in CET. So let me move on to the next problem given in CET. If NC12 is equal to NC8, find N. So you have to recall the formula. We have NCR is equal to NCN minus R. Therefore, NC12 will be equal to NC12 minus rather N minus 12. When you use this formula, NCR is NC N minus R, NC12 should be NC N minus 12, but that has been given to be NC8. Therefore, N minus 2 should be 12, N minus 12 should be 8, that is N is equal to 20. I think got the point. A very simple one. We can work it out provided you remember this. There is one more similar problem. If NC15, this is also CET problem, is equal to NC14, find NC29. So what is the method? NC15 is equal to NC N minus 15. That is given to be NC14. Therefore, N minus 15 should be equal to 14. So N is equal to 29. So what is N? N is 29. 29 C 29 is 1. So there may be some problems based on this. So this is a very, very important formula. Use this. I think one more was there. I don't know whether I've collected it or not. Okay. Let's go to the other type of problems. See, this is a normal question asked in the examination. Remember this. In a party, if everyone handshakes with everyone, how many handshakes are possible? So always remember number of handshakes. This formula I can remember. Number of handshakes is equal to NC. Remember that. What is N? N is the number of persons in the party. I think 1 or 2 years I've asked this question, but they may not ask directly, they'll put it another way. The question asked was, I'll read the question instead of writing it. Everybody in a room shakes hands with everybody else. The total number of handshakes is 45. Total number of handshakes. Handshakes equals is 45. Find the total number of people in the room. You should remember number of handshakes formula is NC2. So therefore what is NC2 should be 45. Number of handshakes possible is NC2. That is given to be 45. What is NC2 that you should remember? What is NC2? What is NCR? NCR n into n minus 1 etc. divided by 1 into 2 into 3. So what is NC2? Write two terms backwards. N into n minus 1 divided by 1 into 2 is equal to 45. So n into n minus 1 is equal to 90. So n square minus n minus 90 equal to 0. Factorize this. N square minus 10n plus 9n minus 90. Can take n common. N minus 10 plus 9 into n minus 10. So n is equal to 10 or minus 9. Minus 9 is not possible. Therefore, n is equal to 10 is the answer. But all this was not necessary. What is the thing? N into n minus 1 should be 90. Product of two consecutive numbers should be 90. Numbers are 10 and 9. No other. It can't be 45 into 2. Because product two consecutive numbers. Directly you can guess n should be 10. Supposing I give the number of handshakes is 42. So n into n minus 1 is equal to 84. Then you can't work it out. You got to work the problem. So instead they may give number of handshakes with 21 they can give you. So n into n minus 1 is going to be 42. So number of handshakes is 6. 7 into 6 is 42. So you can always remember 4 into 5 is 20. 5 into 6 is 30. So consecutive integers. 11 into 12 is how much is 11 and 12? 120 plus 11. So you can calculate like that. So orally you can work this problem instead of solving a simultaneous equation. So the two concepts you need to know is number of handshakes is equal to NC2 and again total number of handshakes. So that 45 will become 90 because n into n minus 1 divided by 2. After this only you should start thinking of what is the possible numbers. It will be so easy provided you remember these concepts. Okay. This is a problem. The number of ways this is a problem from CET. Number of ways in which 5 girls and 3 boys can be seated in a row, so that no 2 boys are together. I'll work 3 or 4 problems or 3 or 4 different types of problems using the same data. Thereby, I will be giving you the total concept of working the problems. Listen carefully. What is the condition? There are 5 girls and 3 boys. You have to arrange them in a row. Totally 8 are there. How many ways you can arrange them? 8 factorial ways. There are 5 girls and 3 boys. How many ways you can arrange them in a row? The answer is 8 factorial. Supposing the problem is 5 girls and 3 boys. If they arrange them in a form of circle, it is 7 factorial. Try to understand the concept. If 5 boys and 3 girls should be arranged in a row, no conditions, it is 8 factorial. If 5 girls and 3 boys you have arranged in a form of circle, no condition, it is 7 factorial. But the problem will not be so simple. What is the condition? What's the condition? No 2 boys should are together. So what you do is you first arrange the girls. How many girls are there? 5 girls. How many ways you can arrange them? 5 factorial ways. 5 girls can be arranged in 5 factorial ways. So I'll write this girl, or G1, G2, G3, G4, G5. So we have arranged 5. I've just written G1. I should not write G1, G2 because they can be put in any place. All possible combinations. So 5 girls can be arranged in 5 factorial ways. Now the boys can be here, or here. Because no 2 boys should be together. How many places are there? 1, 2, 3, 4, 5, 6. How many boys are there? 3. Therefore, the arrangement is 6p3. I repeat. First, arrange the girls. 5 girls can be arranged in 5 factorial ways. Now there are 6 places for boys, so they can be arranged 6p3. Fundamental principle says if one thing can be done in m ways, second thing in n ways, 2 things can together be done in mn ways. So you can arrange the girls in 5 factorial ways. Remember, 5 factorial is 120. But always ask the student to remember 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, 6 factorial is 720. At least up to that. 7 factorial 840, that also you can remember. At least 5 factorial remember. So it is 6p3 into 5 factorial. 6p3 is 6 into 5 into 4 into 120. Multiply this and get this equation. What is the answer? How to multiply this? So this is 30. 30 into 4 is 120. 120 into 120. 12 square is 144. So therefore this is 14400. This is a simple way of multiplying it. I would always ask the student to remember up to 18 square. What is 12 square? 144. 13 square? 169. 14 square, 196. 15 square, 225. 16 square, 256. 17 square, 289. 18 square, 324. 19 square, 361. So if you can remember it and multiply it properly, you get 12 and 12, 144, and 0, 14. Otherwise, it will take a lot of time. I'll keep this 5 boys and 3 girls, 5 girls and 3 boys as it is. Now I'll change, instead of no 2 boys are together, I'll make it no 2 girls are together. So I'll work all possible combinations so that the problem is changed, you should be able to work the problem. No 2 girls are together. So what should you do now? You arrange the 3 boys. Okay. Now there are only 4 places. 1, 2, 3, 4. There are 4 places for the girls, but there are 5 girls. So that is not possible. Therefore, they will not give a question like this. If they want to give, they will make this 3 more than 5. So instead of 3 boys, I make it 7 boys. Then it is possible. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 factorial. So there is no need of writing the diagram, and I am writing diagrams so that you get an idea. But in the examination, if it is asked orally, you can do it. First, you can arrange 7 boys and 7 factorial ways, and there are 8 places. If there are 7 boys, 1 extra. The girls can be arranged in 8C5. That problem cannot be asked in CET. Why? It's a very big one. So let me keep 3 boys as it is. Okay. Now, instead of asking no 2 boys are together, all boys are together. All boys are together. Supposing question is asked like this. So what you should do? Now 5 girls, you can put them anywhere. These 3 boys want to be together. That means if you show the place for one of them, supposing I can say you can sit here. So though they can arrange themselves in how many ways? 3 factorial ways. 3 boys can arrange themselves with 3 factorial ways. Only thing is you have to show them the place. So there are how many girls are there? 5 girls. And these 3 boys can be taken as one unit. Totally 6 person will be arranged. And Damasha one students ಹೇಳ್ತಾರೆ ಆ 3 ಜನ ಬಾಯ್ಸ್ ಇದಾರಲ್ಲ ಅವ್ರನ್ನ ಗೋಣಿ ಚೀಲಕ್ಕೆ ಹಾಕ್ಬಿಡಿ ಒಟ್ಟಿಗೆ ಇರಬೇಕಲ್ಲ ಅದೊಂದು ಗೋಣಿ ಚೀಲ ಪ್ಲಸ್ ಇದೊಂದು ಬಾಯ್ಸ್ 5 ಜನ ಹುಡುಗಿರು ಪ್ಲಸ್ ಒಂದು ಗೋಣಿ ಚೀಲ ಒಟ್ಟು ಎಷ್ಟಾಯ್ತು 6. ಸೊ how many ways you can arrange them? 6 factorial ways. ಇವಾಗ ಗೋಣಿ ಚೀಲ ಬಿಚ್ಚಿ ಎಷ್ಟು ಜನ ಬಾಯ್ಸ್ 3 ways. They can arrange 3 factorial ways if they want to be together. Now, ಇಲ್ಲಿ can be seated row ಬದಲು can be seated in the form of a circle ಅಂತ ಕೇಳೋದು ಇಟ್ಕೊಳ್ಳಿ. I am discussing all the concept with this problem so that overall picture I am giving you. 5 boys and 3 girls be seated in the room in the form of circle when no 2 boys are together. No 2 boys are together. Supposing condition is they only say 5 girls and 3 boys were in the form of a circle. 5 plus 3 is 8. The answer is 7 factorial. Why 7 factorial? Number of permutations of circular permutations of n things taken all at time is n minus 1 factorial. When there is no condition, it is 5 plus 3 8. When there is a condition that no 2 girls are together, so take the 5 girls. Let the 5 girls form a circle. How many ways you can arrange them? 4 factorial ways. Repeat. You have first arrange the girls. If it is a form of a row, it was 5 factorial. Because it's a form of a circle, it is 4 factorial. So now draw a figure. All this mental you should do it, but here I am drawing the figure to give you a clear picture. Girl girl, and girl. One more girl is there. Okay. Now, how many places are there in between? 1, 2, 3, 4, 5. Whereas in the former circle, we had one extra. So, how many boys are there? So, it is 5, 3, 3. So, what is the method? 4 factorial into 5, 3, 3. No two girls are together. You cannot do that. But if all boys are together, then also you can do that. That is same. All the boys are together. So what you can do is one unit afterwards. Supposing no two girls are together, if it is asked, you can't arrange. If all the girls are together, it is possible. If all the girls are together, you can take these 5 girls as 1 unit plus 4 boys. Then you can, only thing is you have got to expand that circle. Okay. So with this, I think I have given you a clear idea of permutations, combinations, and I have not discussed much problems, but I think I have given you sufficient concept. With this, you can work problems. Tomorrow, I will just continue the same chapter because there are some more problems which have been asked in the CET examination. So I will first solve them, and afterwards I am going to introduce binomial theorem. As I said in the last class, kindly go through binomial theorem. Then we shall discuss tomorrow whatever problems that are left over in permutation combination, that we shall first discuss, and then we shall go for binomial theorem. Thank you and good night.